Hello, welcome to all. My name is Sachin Sambhaji Patil. I welcome to all of you for this session on to find out transfer function of RC high pass filter circuit. Okay, once again I would like to welcome to this session. So we'll see how to find transfer function of RC high pass filter circuit. So we know that high pass filter, it is passing the high frequency component and it will be block the low frequency component. It is called as high pass filter. So we can see in this circuit diagram there are two loops are shown, loop number 1 and loop number 2. So we have two methods to find out the transfer function. That is, in method 1 we can apply the Kirchhoff's voltage law to loop 1 and loop 2. We can find out the VIS, input voltage in S domain, output voltage in S domain, and we can take ratio of output voltage in S domain to the input voltage in S domain, and we are getting the output SRC upon 1 plus SRC. This is transfer function of RC high pass filter circuit. Similar way we can go for method number 2. So in method number 2 we are applying the voltage divider rule. So in the voltage divider rule, what is happening? So in case of voltage divider rule, we know that we are measuring the output voltage across resistor R. So what is transfer function? It is a ratio of Laplace transform output to the Laplace transform of input. So we know that what is transfer function. So according to the voltage divider rule, so we are measuring the output voltage across resistor R. So impedance R divided by total impedance of circuit. So that is the ZR impedance of R plus ZC impedance of capacitor. Okay, so ZR output voltage is equal to voltage drop across resistor, because we are measuring the voltage across resistor, divided by total impedance of circuit. So that is the ZR plus ZC multiplied by input voltage. Okay, so we know that ZR is equal to R and ZC is equal to 1 upon SC. So this you have to remember, this is we are using shortcut method. In case of inductor, ZL we have to write here SL, and in case of capacitor you have to take ZC is equal to 1 upon SC. So ZR upon ZR plus ZC, that's R upon R plus S 1 upon SC into VIS. So we are taking the ratio of V out output voltage upon input voltage is equal to R upon, that is the you cross multiply this term and make denominator is same. Then we are getting this R divided by SRC plus 1 upon SC, and this divided you have to convert into multiplications. So numerator goes to denominator and denominator goes to numerator. So we are getting SC upon SRC plus 1. So after rearranging this term, we are getting this transfer function output voltage upon input voltage in S domain is equal to SRC upon SRC plus 1. So this is the transfer function which is indicating Laplace transform output voltage upon Laplace transform input voltage is equal to SRC upon SRC plus 1. Or we know that RC, it is a time constant, it can be any constant. So S upon S plus 1, this is a transfer function of high pass filter, and in case of low pass filter 1 upon S plus 1. Okay, so RC, it may be any constant, this will be any constant. Okay, RC is any constant, that is the time taken by capacitor to charge. Okay, that is the RC time constant. So this is the transfer function of RC high pass SRC upon SRC plus 1. So in method 1, what we are doing, in method 1 we are applying the Kirchhoff's voltage law in the loop 1, then we are taking the Laplace transform of that equation 1, and we are finding the input voltage in S domain. Then loop 2 we are applying the Kirchhoff's voltage law, then we are taking Laplace transform of that equation, we are finding the output voltage in S domain, and then we are taking this ratio of Laplace transform output voltage upon Laplace transform input voltage. Okay, and we are getting the SRC upon 1 plus SRC. And similar way, using method 2, we are applying the according to voltage divider rule. So we are measuring the voltage across resistor R. So R upon, we are taking R plus, that is the 1 upon SC Okay, so this is the we are getting the output, that is the transfer function of RC high pass filter circuit is equal to SRC upon SRC plus 1. This is according to voltage divider rule, because across which component we are finding the voltage, that is the resistor divided by total impedance of circuit. So R upon, that is the ZR, impedance of R upon ZR plus ZC, impedance of R plus impedance of capacitor. Okay, multiply input voltage is nothing but the output voltage. So output voltage is equal to, we are measuring the voltage drop across the resistor, that is ZR upon that is the total impedance of circuit, ZR plus ZC into input voltage. Okay, so this is the output voltage representing, and this is the equation we are getting according to voltage divider rule, and this is the final answer, transfer function SRC upon SRC plus 1. So I am very thankful to all of you for watching this video. Keep watching. Please like my video, subscribe my channel. Okay, thank you very much.